This is Jason Kelly at Tokyo Bay Court, still talking about CU's exciting collaboration with Q Tech down in Kyushu. And what a distinguished guest I have here next. This is Project Manager Amal Chandran from the University of Colorado's LASP, which stands for
Laboratory for Atmospheric and Space Physics.
Yeah.
And Jason, it's a pleasure to be here. Thank you for having me.
Well, thank you. It's a pleasure to be with you, really. I don't get to talk to a space scientist every day, so I'm going to make the most of this.
Pleasure's always mine.
Now, LASP has been in business, been designing for space since 1948.
That's correct. So we started with V2 rockets captured from the Germans. And one of our first payloads was actually something to look at the sun. So keep the pointy tip up, make sure that it's pointed the right way.
That was one of the first things you put on the list, huh?
Yeah, so we had scientists take it out to the top of the physics building and make sure that the pointing system was looking at the right place.
How about that? Now, and that was, just for the record, 10 years before NASA was begun.
That's correct. It was called the Upper Air Lab at that time, and then it morphed into LASP in the 60s, and it's been an exciting journey ever since.
Yeah, it sure seems like it. What are the priorities now?
So we are involved in all the aspects of a space mission. So it starts from conceptual design. Then we write proposals to funding agencies like NASA. So we may be involved as a full mission full mission designer, which involves building the instruments and integrating it onto the spacecraft and operating it. Or we may be building individual instruments. So we have sent instruments to every planet in the solar system. And we also have a couple of projects now that one of them is going to a moon of Jupiter called Europa. So that instrument is called the Surface Dust Analyzer. We are very excited for that. We have a few international missions going on. We are involved with the Emirates Space Agency, actively involved in building collaboratively a couple of instruments and the spacecraft with them.
And that's supposed to go to Mars, right?
That's supposed to go to Mars. So we have a few interplanetary missions. We have some Earth observing missions. So our scientists and engineers are constantly pushing the boundaries to understand our own planet and the solar system. So it's always exciting.
It sure is. Now, the INSPIRE program, that's part of what's happening here. The INSPIRE program is an attempt to create a network of universities and space programs around the world that collaborate, right?
Right, that's right. And INSPIRE stands for the International Satellite Program in Research and Education. Engineers always love acronyms. So it's a University of Colorado initiative. And what we've been seeing lately is that there is an international need for space technology capacity building. Mm-hmm. In the last 15 years, about 40 countries have built and operated their first satellites. And the projections are that in the next 15, another 60 is going to do that. So there is a need for space technology education. And we see this as an opportunity for the University of Colorado to take a leadership role in this emerging sector. So we are putting together programs where we are bringing together a consortium of similar like-minded spacefaring universities.
Yes.
And we have students coming from all these universities working on a common space mission and actually building flight hardware. Imagine, Jason, if you had the chance to build flight hardware when you were a student, it's a unique opportunity. You can actually build it, get it to space, and operate it.
Yes, without a doubt. And now, I guess CU, as the coordinator of the program, decides, for example, which satellites are needed, and then would say, all right, we need a satellite that's going to look at the radiation coming off the sun. And they would say, how about Ghana builds that one? Or how exactly does the allocation work?
I wish it was that simple, Jason.
I'm sure you do.
So the first satellite that we are building is looking at the layer of the Earth called the ionosphere. So the ionosphere is where there are a lot of charged particles in the upper atmosphere, and it's an exciting part because it reflects radio signals. So you use it a lot for the UHF radio communication. And the ionosphere densities affect your GPS. That's very important because
Yes.
if the plasma changes, you have errors and you might not be where you think you are. So, so the satellite looks at ionospheric densities. It's a small satellite about the size of a bread loaf. You might think it was easy to get a consensus on what we should build, but if you are ever in a room with a bunch of scientists, getting consensus is the most difficult thing, believe me.
Well, who's actually building that one?
So the payload is actually being built by Taiwan. And the launch is going off the Indian Space Research Organization's Polar Satellite Launch Vehicle, and the spacecraft is being built in Colorado.
How exciting that international teamwork.
This is how it should be, because the satellite, where it works, there are no borders. So why should we have where we build it?
Yes, that's right. That's right. From space, there are no borders, right? Well, I'm curious. I love space topics. I'm no expert, but I just love the topic of space. And one of my favorite books about extraterrestrials is Stephen Webb's book. Yes, here it comes. Brace yourself. Stephen Webb's book, Where is Everybody?, which attempts to answer the Fermi paradox that if the universe is teeming with aliens, then why don't we see them? Where are they? And I have to ask a space scientist, do you believe in the existence of extraterrestrials?
What are the odds?
You tell me.
It must be teeming with life.
Then where are they? No, I won't put you on the spot, but you do believe that.
I do believe that, and I'll give you a simple reason. And I want to tie that with the University of Colorado again.
Okay.
So we have something called the Kepler Space Telescope.
Yes.
It's looking at a neighborhood of our Milky Way galaxy, and the spacecraft is actually operated by the University of Colorado, LASP. So our students run the telescope, and we have been looking at a region of space looking for planets around these stars. And we have found that almost all the stars have planets around them. And 20% of them are in what is called the habitable zone.
Yes.
Right, where liquid water will exist.
Yes.
Now, if you look at our solar system that we know of, have sample size of 1, we have 3 planets there: Venus, Earth, and Mars. Venus is too close, Mars is too away, and Earth is in the right place.
Yes.
1 out of 3.
Yes.
Right. Now that I agree that's a fairly ambitious statistic to throw out there, but
We'll call it optimistic, not ambitious. It's optimistic,
Right.
because who doesn't want the answer
if
to be
you
yes?
extrapolate that and put that into the Drake equation, you're going to get billions of planets that are habitable in
Yes.
our galaxy.
Yes, that's
And
right.
I think in our lifetimes, the next generation of space telescopes is going to find planets with evidence of oxygen in the atmosphere.
You heard it here first. That is wonderful to know. And you know what I love about the end of Webb's book is he said something that stuck with me over the years, and that's that the answer to the question of whether life exists in outer space is overwhelming regardless of what it is. If there's nobody out there, that's overwhelming.
It's a whole waste of space.
Yes, literally a waste of space, right? And then on the other hand, if it is teeming with aliens, it's equally overwhelming.
True. It may also be that we are not looking the right place. We are looking for radio frequencies that we can see, that we understand, and it may just be embedded in the noise. You have the star which is dimming. I don't know if you know what I'm talking about, but
Excuse me. Yes, I do. I do know what you're talking about.
Right. So we have proposed that it may be some kind of alien structure that's causing the periodic dimming of that star, for example. So it's exciting. I think we are in a very exciting era of planet hunting.
Sure.
Kepler has thrown out thousands of habitable planets. The next generation of space telescopes, James Webb, WFIRST, these are telescopes that's going to go up into orbit in 5 to 10 years. James Webb should be sooner, I hope. And then, I think we'll make some exciting discoveries. It's a good time to be in space technologies right now.
Yes, without a doubt. And you have an interest in low Earth orbit satellites, and you were mentioning earlier GPS. And I know with mobile phone technology, has your skill set become more and more valuable over time?
I think it's worked both ways. So most of these applications, for example, you always looking at weather.com, right?
Sure.
On apps, but you want to know. People have a need for knowing real time. Things like weather. So the computer models have also gone up to where we don't have enough observations to feed into these models. So there is a dearth of relevant information that can be given from space technology for all the things that we do. And the other way is that the miniaturization has helped in what I just told you. The spacecraft we're building is only the size of a loaf of bread.
Right.
These used to be 100, 300, $400 million spacecraft. Now you can do comparable science, not the same quality, but comparable science from spacecraft that's 100K, 200K, or less than $1 million.
How about that? And it's just going to keep going that direction.
It's going that way. The largest satellite operator in the world right now is a company called Planet. Based out of California, and they have these small satellites in constellations that are constantly imaging the Earth, and you can use that data for real-time weather forecasting, disaster management, or even looking at how many cars are there in the parking lot of a Walmart.
Very useful stuff, that. It really is. When you spend your day in the heavens, almost literally thinking in the heavens at least. And you're on these kinds of topics. Is it hard for you to care about petty news?
Well, it's hard to care about the news that's coming back home these days, anyway. But no, I find it interesting. I listen to NPR on the way to work and back. You should really ask my wife that question. Yeah, she claims that I never care about daily life anyway. But just before I got on the plane here, I have 10 interns who are working from working on the satellite project.
Yeah.
And the discussion at lunchtime was about Star Trek and Star Wars, or was Firefly the greatest sci-fi series ever? So
Some real world stuff.
Yeah, and was that sci-fi movie about potatoes or corn the best? So yeah, we have those discussions as well.
Good to know. And I'm guessing you and everybody you work with would jump at the chance to go into space.
Well, I know a lot of people who build the spacecraft, so I'll wait a while.
Okay, we'll leave that for what it is. Okay. Well, thank you very much for joining me today. This has been
Jason.
illuminating.
A pleasure to talk to you.
Yeah, and good luck with the collaboration with Q-Tech.
Oh, well, we are excited about that. Q-Tech is in the Eastern Hemisphere, they're a world leader in space technology education. So we are very excited at the opportunity to work with them.
I'm excited for both of you. Thank you, Amal.
Thank you, Jason.